This is a special video just on identifying outliers. Let's look at an example. A large insurance company is studying the claims filed by its clients for auto accidents over the past year. The company decides to group the clients by region to see if geographic location is a factor. A complete history. That word, complete, is very important. History of a region's claims are compiled, and the average number of dollars paid out per region, or for this particular region, is calculated to be $2.59 million with a standard deviation of $0.83 million. We have a couple questions. A is, what would, or would any of the following regional payouts be considered an outlier, right, or payouts in the region? So we're just trying to identify, are any of these outliers? Now, what's going to be important is these two numbers here, the mean and the standard deviation. Right? Because it's a complete history of the region's claims, is this a sample or is this a population? Right? It would be population because it includes everything. It's a complete history of the region's claims. So when we start calculating lower and upper boundaries, we have to keep that in mind. So we're using standard deviation and not sample standard deviation. So what we need is lower and upper boundaries for outliers. If you remember our yak example, I'm just going to pull this back up. Right, we have our typical, unusual, rare outlier. Well, we're just trying to identify outliers. So all we need are those particular boundaries. We actually don't care about anything really in between. So what we can do is say, well, this boundary is 3 standard deviations above the mean. This is 3 standard deviations below the mean. And so we can just write it like this. Right? And of course, this is the Greek letter mu, and it represents population mean, because that's what we have here. So this is mu, right? And this is our sample standard deviation. Right? This is not division. I'm just sort of highlighting. Make that a little bit more clear. And so we can start plugging in those numbers, and we get our lower bound and our upper bound. And it turns out that because 5.66 is greater than the upper bound of 5.08, it's an outlier, and which is, of course, 5.66 is this one, right? And then 0.08, this one is lower than the lower bound, so it's also an outlier. Now, this is an example where you're given your population or your mean and standard deviation, whether it's population or samples, doesn't matter, but you're given it. Now, that's not always the case. Let's look at a different example. There was actually 2 questions before we get to the other example. If any outliers exist, what response to them would you suggest? This is actually a fantastic question because it's why we do statistics. Right? We have identified these. What does that mean for this insurance company? So my response to the 5.66 region would be to be concerned over the excessively high amount of payout and investigate why it should be so high. Like, what's going on in this region? That's why we're doing this. Right? And now my response to the 0.08 would be to commend such a positive record. Right? Because we're an insurance company, we don't actually want a lot of payouts because that reduces our profits. So whichever region has this 0.08, man, great. Whatever they're doing, it must be right. So that would be my response to these 2 identified outliers. Now let's look at the other example. So we have a small colony of Pacific walrus. And it's been identified, and the mass of each walrus is measured somehow, very carefully, and is provided below. Are there any outliers in this sample? Now notice the difference between this example and the first one. Right? The first one we were simply given the mean and the standard deviation. Here we aren't given the mean and standard deviation, we're given a sample. And so what we're going to need to do is calculate the mean and sample standard deviation. And I'm going to do that using my graphing calculator. I'm show you how to do this, and you're gonna love this function. You can see that I've entered in the walrus mass in L1. Now, what's this whole one var stats business? What I'm going to do is go second quit, so I get to my home screen. If I hit the stat button, right, we have edit, calc, and tests. I'm going to move over to calc, right, and up here we have one var stats and two var stats and a bunch of other stuff, regs. We're in one variable statistics, so let's choose one var stats. We need to tell it which list that we're using, which in this case we're using L1. And we hit enter, and look what happens. It gives us just a whole list of measures without having to do any other calculations. Right, here's our x bar, this is our sample mean. Right. Sx is our sample standard deviation, so we just use S for that. Right, so here we have 9.7, and this of course rounds to 7.0. We have, if this was a population, this is the number we would use. Of course it's not, it gives us our n. This little arrow right here means let's go down. We have more stuff going down. Right? And this, right, min, Q1, med Q3, this is also part of the box whisker information system. So you'll learn about this in another video or two, but it's good to know that all of this is in this one var stats. It's a great function. It gives you lots of information very quickly, very easily. So let's get back to over here. Right, we have our x bar and our S, our sample mean and sample standard deviation. We can get our upper bound and our lower bound in the same way we did before. We plug in the numbers, we get our boundaries, and we can conclude that actually there is a walrus, this 4512, this guy right here, is greater than the upper boundary of 4410. So it's an outlier. Right? That's one big walrus is what we're figuring out. Or, I don't know, is it a big walrus or did we measure it wrong? We should probably investigate. Now, there's an interesting second question, which is if a new member of the walrus colony is discovered. Right? We were trying to get the entire colony. Right? We thought we did. All of a sudden, oh, this walrus was out hunting, came back. Excuse me. You know, if we want to get statistics on this whole colony, we better measure it. And so we do, and we have, turns out to be 4,412 pounds, right? And we add that to the data, right? So we actually put it in the data list. And the question is, would it be an outlier? Because, yeah, right, here's our upper boundary, 4,410. It appears to be bigger. Would it be an outlier? The answer is we don't know yet, because our data set has now changed. So our x bar and our S are also going to change. So we need to recalculate. So here we do one var stats again. We get the new x bar and new S. Notice that both the mean and in particular the sample standard deviation has really increased quite substantially. We go through the calculations, and look what happens to the upper and lower boundaries. They really spread out. What conclusion do we now draw? Oh, actually, with this, there are no outliers at all. The one that used to be an outlier over here is 4512 is actually less than the upper boundary now, so actually there aren't any outliers anymore. So it's kind of interesting what can happen if you start adding new data. So you do have to be careful when you do that.